In this lesson, we are going to look at more detailed algebraic examples of inverse variation. Inverse variation is in the form of y equals k divided by x. And when we're talking about x and y, the relationship they have would be that as x increases, your y variable will decrease. So your constant is the product of x and y, which if you look at the general form, you just multiply both sides by x to get k equals x times y. Given the following ordered pairs, find the constant of variation. Now, if you didn't know what type of variation this is, you test it. First, you see if I multiply x times y together, do I get the same constant? Is it a product? So if you do that, -5 times 2.4 results in -12. -3 times 4 is -12. -2 times 6 is also -12, so this is looking good. All right, so I got it. My constant of variation is -12. So I could say x times y equals -12, or y is equal to, in general form, -12 divided by x. Next, I'm told the variable y varies inversely as x, and y equals 12 and x equals 7, so find the constant. So I know that the constant is a product. It's x times y. So if I just do 12 times 7, I get 84. Therefore, my constant is 84. So what's my equation? Well, again, y is equal to k divided by x. So it's y equals 84 over x. Next, I'm told to find y when x equals these different values. So I just like to set up a table here, x, and again, y is 84 divided by x, 5, 10, and 16. So I'm just going to substitute. Let's see, 84 divided by 5 is 16.8. 84 divided by 10 is going to be 8.4, and 84 divided by 16 is 5.25. Next, I'm asked, if the following ordered pairs represent inverse variation, find the missing value. So I'm given an x and two x's and y's, and again, I know that if I find their product, it gives me k. So if I do 4 times 0.2, that has to be the same as the product of x and 8. So 4 times 0.2 is 8/10, and 8 times x is best written like this. To solve this equation, if I divide both sides by 8, I get 1/10, or 0.1.